First of all, I would like to state for the record, this is not how I anticipated this lesson going. So, due to that, I have no blank copies of my notes. Well, I do, I just don't have any printed out, and I don't have a printer at home. So we're going to make do with what we've got, which is, you get a video of me talking you through my notes. If we need to go back over this whenever I get back to school, we can, but that's for another day. So these are your 5-3 notes, which you have them uploaded to Google Classroom already. Or, you can follow along with me to the best of your ability. So rational number, your rational numbers are any number that can be written as a fraction. So these can be whole numbers because any whole number can be written over 1, or it can simply be a fraction, or it can be a decimal that is able to turn into a fraction, which means it terminates or it repeats. So number 1 is super simple. It's reducing 72 over 90 to lowest terms. If you notice, I have a whole hodgepodge of how to do this. What the book teaches is to do its prime factorization. So break down 72 into 2 times 2 times 2 times 3 times 3, and break down 90 into 2 times 5 times 3 times 3. Write your factors over top of each other, cross out what they have in common, and find the product of what you have left. So on the top, you have 2 times 2, which is 4. On the bottom, you simply have 5. 4/5 is your answer. That is a really complicated way to do this. A way that is typically easier that you're taught is find the number that you know that 72 and 90 have in common. They have a 9. 9 is just an easy way to start. So if you divide 72 by 9, you get 8. If you divide 90 by 9, you get 10. Well, that you can still reduce. You can reduce both of those by 2, which gives you 4 over 5. If you know right off the bat that 72 and 90 are both divisible by 18, you could start there. But typically we start with what we are more comfortable with rather than 18. But be my guest, just do me a favor, just don't type it in the calculator. Number 2 is converting a mixed to an improper. There we go. So what you do is you multiply your whole number by the denominator, then you add the numerator. And anytime you've got a negative, you ignore that until the very end. So if we've got -2 and 5/8, we're just gonna write that negative out front. That's all we're gonna do. You multiply the whole number by the denominator. So 2 times 8, add the numerator. 2 times 8 plus 5 divided by 8. Well, you do your order of operations first. 2 times 8 is 16. 16 plus 5, that's where the 21 comes from. We throw that negative back in there, so we get -21 over 8. Number 3 is how you convert a improper to a mixed number. You divide the top, that's supposed to be a top, there we go, by the bottom, and put the remainder over the denominator. So we divide 16 by 3. If you do this in the long division style, 3 does not go into 1, but 3 goes into 16 5 times. 3 times 5 is 15. We do a subtraction here, so that's our remainder. So 3 goes into 16 5 times with a remainder of 1, which means that's 5 1/3. I know you know how to do that without using a calculator. It's just jogging your memory. Just like, you know how to do number 4. We are doing long division with decimals. Ooh la la. So if you've got 3 divided by 8, always start by putting your numerator in the box, put your denominator on the outside, and I tend to start with 3 zeros just to be on the safe side, and that's really light for you guys to see, isn't it? I don't know if it's my phone's brightness or if it's just the pencil lead, but it is 3.000. Might be the pencil lead. Well, 8 does not go into 3, so we put a 0. 8, however, does go into 30. It goes in 3 times because 8 times 3 is 24. So 30 minus 24, that gives us 6, and we bring down a 0. 8 goes into 60 7 times. 8 times 7 is 56. Do that subtraction, you get a 4. Bring down your 0. 8 goes into 40 5 times. That gives you 40 with a remainder of 0, which is why our decimal is 0.375, because you have nothing left over. So for B is 5 divided by 11. And we're going to talk, well, I guess we don't talk about these rules. 5 goes in the box, 11 goes on the outside of the box. We start, if you can't tell, my zeros are a little bit different. You start with 3 and then you add on if you need to. So 11 goes into 50 4 times. That gives you 44. Do your subtraction, you get 6. 11 goes into 60 5 times. That's 55. Do your subtraction, you get a 5 again. When you bring down your 0, 44. And if you notice, it repeats a pattern. So it is just 0.45 repeating. And then. So 5 is all about expressing each decimal as a quotient of integers reduced to the lowest terms. You know, write it as a fraction. Easy peasy. If you have 1 decimal place, you're going to put it over 10. If you have 2 decimal places, you put it over 100. And if you have 3 decimal places, you put it over 1,000. 4, you would put over 10,000, 5, so on and so forth. So, 0.9, you're going to put 9 over 10. 9 over 10 does not reduce, so that problem's done. For B, you have to put 86 over 100. 86 and 100 are both divisible by 2. 86 divided by 2 is 43. 100 divided by 2 is 50. Make sure you reduce if possible. C, you've got 1, 2, 3 decimals, which is why it has to go over 1,000. So you put 53 over 1,000. There's nothing that 53 and 1,000 have in common besides a 1. So that one is reduced to lowest terms, and we move on to the next page. So your next page has this nifty little chart up top, which simply says, if you have 0.1 repeating, 0.2 repeating, 0.3 repeating, so on and so forth, anytime you have a repeating, it's a number over 9, which means this is 1 over 9, 2 over 9, 3 over 9, 4 over 9, 5 over 9, 6 over 9, 7 over 9, 8 over 9. Likewise, if you have I'll word that differently here in a minute, because that was not going to get worded correctly if I tried it right then. Number 6 says express 0.2 as a quotient of integers. No, it's right here. I just told you it was a number over 9. So it's literally 2 over 9, and that's all you do with that. Express 0.79 repeating as a quotient of integers. That's 79 over 99. So however many decimal places you have repeating is divisible by 99. Meaning our one that we just did over here, oops, this guy, that 45, that 0.45 repeating, that started as a 99 and then it was reduced. Back over here, where'd my problem go? So for example, if we had like 0.818 repeating, it would be 818 over 999. So however many decimal places you have repeating is how many 9s you're going to put it over top of. On 8, you're multiplying. Multiplying is really easy. You multiply across the top and you multiply across the bottom, and then you reduce if possible. So on A, you're going to do 3 times 5, which is 15. And then you're going to do 8 times 11, which is 88. 15 over 88. They have nothing in common. You're done. B, across the top and across the bottom. Now, that's a negative, that's a negative. A negative times a negative, we should know at this point, is a positive. 9 times 2 is 18. 3 times 4 is 12. Well, 18 and 12 are both multiples of 6. So 18 divided by 6 is 3. 12 divided by 6 is 2. So our final answer is 3 halves. C, this C, not the other C. C is a little bit different. You need to change this into a improper fraction before you multiply. So we're going to do 3 times 3 plus 2. Which is 3 times 3 is 9, 9 plus 2 is 11, so 11 thirds, times 1 times 4 is 4 plus 1 is 5, 5 fourths. So we get 11 times 5, which is 55, 3 times 4, which is 12. We have 55 twelfths, which we could change back into a mixed number if we really wanted to, but it's not exactly necessary, just kind of up to you. moving on. When you dividing by fractions or dividing with fractions, you keep your first fraction, you switch your operation to multiplication, and you flip your second fraction. Mr. Warner, I know, preaches this. Keep, switch, flip. I know the man does this, so if you've had Mr. Warner, you've heard this before. A is 9/11 divided by 5/4. You keep your first fraction, flip to multiplication, and switch to multiplication. There we go. Flip your second fraction. So you get 9/11 times 4/5. 9 times 4 is 36. 11 times 5 is 55. That's all you got to do. B, keep, switch to multiplication, flip your fraction to 5/2. Negative 8 times 5 is negative 40. 15 times 2 is 30. If you notice, they both end in a 0, so I can cross those out, and I'm left with negative 4/3. C, moving my packet around. C is another one where you need to change it to an improper instead of a mixed. So you're going to do 3 times 8, which is 24. 24 plus 3 is 27. So you get 27/8 divided by, currently we're still keeping it as a division. 2 times 4 is 8 plus 1 is 9, 9/4. Now switch it. So 27/8 times 4/9. And you've got an option here if you really want to. You can multiply across the top and get 108, across the bottom and get 72, and then reduce that. You've got to know that 36 goes into 108 and 72. Or sometimes what I think is easier, let's see if I can write this one-handed without holding my paper and without messing up too badly. 27/8 times 4/9. Well, 4 goes into 8 twice, so that becomes a 1 and that becomes a 2. And then 9 goes into 27 3 times. That becomes a 1 and that becomes a 3. 3 times 1 is 3. 2 times 1 is 2. 3 halves. You get the same answer if you reduce before you multiply. So you do have the option to do that. Let's see. 10. You are performing the indicated operation. So on these ones, on all of these ones on the bottom, we are either adding or subtracting our fractions. To add or subtract fractions, you have to have common denominators. And then once you have a common denominator, all you do is either add or subtract the bottom. Sorry, got distracted. You only focus on the top. You leave the bottom completely alone. So A, you've already got a common denominator. You've got 12 and 12. 5 plus 3 is 8. 8/12 reduces to 2/3 because both are divisible by 4. You still have to reduce. You cannot leave it as 8/12. B, again, super simple. You've already got 4. 7 minus 1 is 6. 6/4 reduces to 3/2. C is your first one that is slightly more complicated. And I say slightly because it's not overly complicated. You can do this math without changing it to impropers. You can do -3 minus a -1, and that gives you, -2. And then you can do -3/8 plus 1/8, which gives you 2/8, and then we reduce. That's a lot. That is a lot. Or you change it to an improper where you do 3 times 8, which is 24, plus 3, which is 27. And then 1 times 8, which is 8, plus 1 is 9, so 9/8. And -27/8 minus a -9/8. A double subtraction becomes a positive. So -27/8 plus 9/8 is -18/8, and then we reduce that all the way down. You can leave it here. You would be fine to leave it here as an improper. I'm okay with that. Or you can go ahead and change it back into a mixed number. I'm okay with that too. Believe it or not, I'm not actually picky about how you write your answer. I would just rather you actually write out your steps than type it into a calculator. D is your first one where you have non-common denominators. You've got a 5 and a 4. You cannot add that together as it sits. So you have to find the smallest number that 5 and 4 go into, which, grade or least common multiple, which we just went over. You have the option of doing your prime factorizations, or I have a lot of kids that just, all right, if this is a 5 and this is a 4, I'm going to multiply this by 4/4, and I'm going to multiply this by 5/5. And that way, I don't have to think. That's fine. So that is the way we actually do this least common denominator, because it's 20. The smallest number that 5 and 4 go into is 20. So you've got to multiply 1/5 by 4 over 4 and 3/4 by 5 over 5. The reason we do that, in case you have forgotten, and however many years it's been since you covered this, 4 over 4 is 1. 5 over 5 is 1. Essentially, you're not changing the value of your equation at all. You're just changing what it looks like. So 1 times 4 is 4. 5 times 4 is 20. 3 times 5 is 15. 4 times 5 is 20. You've got 4 20ths plus 15 20ths. 4 plus 15 is 19. 19 over 20 does not reduce. And we leave it alone. E, you've got 10 and 12. This is one where if you do your least common denominator or the least common multiple of 10 and 12, you're going to get 60 because 10 times 6 is 60 and 12 times 5 is 60, which is the way the example is done right here. I multiplied 3/10 by 6 over 6. I multiplied 7/12 by 5 over 5. That gave me 18/60ths minus 35/60ths. And when I subtracted, that's negative 17/60ths. You have that option. If, however, you want to do it the other way, where you do, I have no idea where that 7 came from. If you do 3/10 and we multiply by 12 over 12 minus 7/12 times 10 over 10, that is going to give me 36 over 120 minus, sorry, again, I'm trying to write this one-handed without moving my paper while I'm holding my cell phone, minus 70 over 120. 36 minus 70 is a negative 34. So you've got negative 34 over 120, which ends up reducing. That reduces to this negative 17/60ths. So you're going to get the same answer no matter if you go the easy route and just multiply by the other denominator or if you go through and find your least common denominator. And then, because we're still not done, sorry, dropped my phone. 11, you've got to simplify, which means you're doing PEMDAS. You're doing PEMDAS with fractions. So PEMDAS means we start with parentheses. The only set of parentheses that we actually have an operation in is this one. We need to do subtraction. Unfortunately, they're not common denominators, which means you have to find your common denominator. In this case, between 10 and 15, your least common denominator is 30. If you want to do it that other way, be my guest. This way is just going to be easier on you. So to get 10 to 30, we multiply by 3 on both sides, our top and bottom. So that would be 3 over 3. To get 15 to 30, it's 2 over 2. So 7 times 3, that's where the 21 came from. 18 times 2, that's where the 16 came from. And then to get from here to here, 21 minus 16 is 5. 5 over 30 reduces to 1/6. So that's where this came from. The 1/4 came from negative 1/2 squared. That's 1/4. And then that negative 18, we're just going to keep dragging it down. So at this point, that's where we are right now. You still have to do your exponents. 1/6 squared is 1 squared over 6 squared, which is 1 over 36. Then you've got to do multiplication. Sorry, the dog just opened the door by herself. You've got negative 18 times 36, which is a, negative 1/2 because 18 over 36 reduces to 1 over 2. And when you subtract a negative, it means you're adding. Well, 4 and 2, again, are non-common denominators. Your common denominator between 4 and 2 is 4. So you've got to get the 2 to a 4. This problem's kind of a nightmare, to be honest. It's not too bad. It's a lot. And I know it's a lot. 1/4 plus 2/4 is 3/4. Try it, please. Number 12 is find the rational number halfway between 1/3 and 1/2. It's like finding the average. So what you do is you add 1/3 and 1/2 and you divide that number by 2. Again, non-common denominators. Your common denominator would be 6. So to get a 3 to a 6, you multiply by 2 over 2. To get a 2 to a 6, you multiply by 3 over 3. So now we go to 2/6 plus 3/6. 2/6 plus 3/6 is 5/6. Well, if you're dividing by 2, it's the same as multiplying by 1/2, because dividing by a number is the same as multiplying by the reciprocal. So 5 times 1 is 1, 6 times 2 is 12, 5/12 is halfway between 1/3 and 1/2. And then last problem, I promise. And the last problem, God love it, has absolutely nothing to do with what we've been doing. I really can't figure out why it's in this chapter, to be honest with you. A chocolate chip cookie recipe for 5 dozen cookies requires 2 eggs. If you want to make 7 dozen exactly, how many eggs are needed? Then round to a realistic number. Well, for 5 dozen cookies, you need 2 eggs. We're trying to make 7 dozen cookies, so how many eggs do I need? This is a proportion. To solve proportions, you cross multiply. You do 5 times x equals 2 times 7. Remember that little butterfly thing that you do in 7th grade? So 5x equals 14. X equals, you divide, and you get 2.8. I'm sorry, y'all, you cannot get 2.8 eggs. Not possible. So your realistic number, you need approximately 3 eggs. So that is the entire lesson. I know you can do every single one of these with a calculator. I want you to try it without a calculator. When you go to take your quiz, you are allowed to use a calculator. I'm giving you a calculator on the quiz. I'm not taking it away, so nobody have a meltdown. But just see if you've got enough brain power to do it without it before you get it out, please. Your homework is page 284, numbers 4 through 108, multiples of 4 and 130. Multiples of 4 means 4, 8, 12, 16, 20, 24, 28, 32, ... You're adding 4 each time, children. If you have questions, let me know. Email me throughout the day. I can answer them, okay?